Alright, so here we have a little bit of a challenging AP physics question. So yeah, let's try and solve this. So the question says, the figures above show a small block of mass 0.20 kilograms on a track in the shape of a circular arc. The block is released from rest at height h above the floor. So it's released from this height above the floor, as shown in figure 1, correct? And the block slides along the track with the negligible friction. That just means no friction. We don't have to worry about friction. Write this down, no friction. And it leaves at a height of 0.40 meters above the floor and at a speed of 3.0 meters at a 30-degree angle as shown in figure 2. So this is just this part, the launch part. So it's asking the height h is most nearly. So to do this, we need to develop a equation here. So the first thing we need to realize is that as the box is coming down all the way from here to here, it does have a potential energy, right? And until here. So we're going to have an initial potential energy. So I'm going to write this down. So we're going to have a potential initial, right? And this is going to be equal, right? It's going to be kind of equal to you're going to have a final potential energy plus a kinetic energy, correct? So to do this, let's sub in what we know. We know that the potential energy is equal to mgh, which is mass times gravity times the height, and our k is equal to half mv squared. Alright, so let's do some substitutions. So this is going to be mgh, which is the h that we want. So I'm going to make it a capital H, right? And this is going to be equal to just regular mgh on its own, right? I'm going to call this h2, why not? Plus half mv squared. Now if we notice this equation here, to simplify our calculations at the end, we can cancel out something common in between all of them, which is our mass. So we can cancel out, divide by mass on both sides, so we can get rid of this mass. And so we'd be left with the equation g times h is equal to gh2 plus half v squared. So now I'm going to divide this g out, right? So it's going to be h is equal to gh2 plus half v squared divided by g. So now all we have to do is plug in our numbers and we should get our answer for h. So h is going to be equal to, I'll do that in red, because why not? So h is going to be equal to 9.81 ms squared times the original, our secondary height, which is 0.40 meters, plus half times the velocity it's being launched at, which, let's look here, is 3.0 meters per second. And it's getting squared. And you're going to be dividing this by 9.81. Okay? And if you do all these calculations, you plug everything in together, you should get an answer of 0.86 meters. So the initial height, right, that it's being released from is 0.86 meters. And that is our answer to this question. Hope it helped. Have a good day.